so here we go. We're practicing or we're reviewing our factoring that we looked at on Friday. So on Friday we said, what do you multiply to get 12 that you add to get negative 7? Now, I teach it with the x, and we say, what do you multiply to get 12 that you add to get negative 7? You can also do it with the table. What do you multiply to get 12 that you add to get negative 7? Now, if you do it with the table, then right here you're listing all the things. How can I multiply to get 12? Well, 1 times the number always works. It's even, so 2 goes in it. Let's see, 3 goes in there 4 times, and that's it. Those are the only way we can multiply to get 12. Now, either all these are positive or all these are negative. And the one that works is negative 3 times negative 4 because it multiplies to give us 12 and it adds to give us negative 7. So that's how we're going to break it up into negative 3 and negative 4. So it becomes x minus 3 times x minus 4. All right, now the next one is a special one. This is a difference of squares. And some of you probably noticed that right off the bat. And you went, ooh, this one factors to the square root plus the square root times the square root minus the square root. But if you didn't, how do you do it? What do I multiply to get negative 16 that I'm adding to get, well, there's no middle term. So we would have to think in our heads that I'm adding to get 0. Well, if I'm adding to get 0, they have to be opposites. And the only way I can do that is positive 4 times negative 4. Add them to get 0, multiply them to get negative 16. Now the last one, what can I multiply to get negative 32 that I can add to get negative 4? So if you do it with the x, it's going to look like this. If you do it with the table, we might just go through our list. 1 and 32, 2 and 16, 3 doesn't go in there, 4 and 8. I can really stop now because 4 and 8 will work. I'm multiplying to get a negative, so they have to be opposites. And I'm adding to get negative 4. So if I do positive 4 and negative 8, it works. Positive 4, negative 8. So this factors to x plus 4 times x minus 8. Now, if you wrote x minus 8 times x plus 4, is that right or wrong? That's correct. It is right. Because multiplication is commutative, the order of our parentheses doesn't matter. What does matter is the sign that's with the number. Do you see the negative is with the 8? The negative is with the 8? That's what matters. But the order of our binomials doesn't. This binomial can come first or second. Any questions about our factoring? Okay, we're going to use this in today's lesson. Today we're going to learn how to graph. I'm going to make this a little bigger. By factoring. Okay, what this is called is graphing using intercept form. And the reason we call it intercept form is because in this graphing method, what we're looking for are x-intercepts. So please add that at the top of your page. Intercept form means I'm going to be using my x-intercepts. Now, to do intercept form, what we try to do is take our quadratic function and factor it. Intercept form means I'm going to start off with the factors. Real quick, who remembers what quadratic means? What does that tell us about the degree of our polynomial if it's quadratic from last semester? Does anybody remember? It's 2. It's the second degree. Quad, you know, a lot of times quad does mean 4. But quadratic tells us it's a second degree polynomial. Okay, so what do we do if we start off with a quadratic function, like y equals x squared, to graph it? Now, this y equals x squared is what we call the parent graph. There's nothing extra. There's no numbers at all. It's just the x being squared. And this ends up giving us this graph. Now, when we learned how to graph initially, do you guys remember we would test some numbers? If I plugged in -2, -1, 0, 1, and 2. Well, if I plug in -2, what's -2 squared?
4.
4. If I plugged in -1, what's -1 squared?
2. 1.
1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. Do you see where this graph comes from? So a quadratic is in this what shape? What do we call that? Does anybody know the name of this? It's a parabola. This is a parabola. Okay. Today, we're going to graph these parabolas using our x-intercepts. We're going to find the x-intercepts, and they come from factored form. If it's factored to x minus something times x minus something, my x-intercepts are those somethings, the a and the b. Now, look at this parabola. Does it look symmetric? Yeah. That is one of the characteristics of a parabola. It is always symmetric. And this line that it's symmetric across is called the axis of symmetry. A parabola is always symmetric, and the line that it's symmetric across is called the axis of symmetry. Now, this point that sits on the axis of symmetry, does it look like it's at the bottom of that parabola? It is. And we call that point the vertex. That is the vertex. Okay, so add these things to your notes. Draw in the axis of symmetry. Identify your vertex. Now, do we see that this parabola keeps going left and it keeps going right? So if I talked about its domain, does it make sense that it would be from negative infinity to positive infinity? Because this parabola goes forever left and forever right. And when we're looking at our domain, that's what we're looking at. What are the possible x values for this function? All of them. Yeah. Now, generally, we write domains and ranges in interval notation. So we would write them like this. On a standardized test, you might see this, or you might see the words all real numbers. Those two things mean the same thing. All right, now range. Range is talking about all of our possible y values. And when we look at this picture, do you see that that's our lowest y value? What is the y value right here at the origin? 0. So this goes from the lowest value, which is 0, and it goes up forever, doesn't it? Well, we describe up forever with infinity. Now, this domain will always be the same on a quadratic function. The domain for every quadratic function is from negative infinity to positive infinity. But the range is going to change depending on how we move that parabola around. Okay, any questions so far about our parent graph, the y equals x squared? This is called the parent graph because we've done no transformations whatsoever. There's no stretch, there's no compression, there's no shifting, there's no reflection. This is the parent graph. There's no extra numbers with it. And this is what we get from the parent graph. Now, let's take a look at what happens when we move that parent graph around. And we're going to go nice and slow to start with. Okay, this is a quadratic that's been factored. And the reason I know it's a quadratic, if I multiplied this back, wouldn't x times x give me x squared? So it's a quadratic. I know it's a quadratic because x times x gives me x squared. Now, when I have a quadratic function in factored form, what I want to do to find the x-intercepts, let's think about this for a second. Any place on the x-axis, what is the y value? Any place on the x-axis. Like if I put a point right here, what's the y value for that point? If you were thinking about the ordered pair. 0. If I put a point right here, what's the y value? 0. The y value, any place on the x-axis, is 0. So when we're trying to figure out our x-intercepts, we want y to be 0. Well, let's look at this. What could I plug in here for x that would make y 0? Positive 3. So one of our x-intercepts is positive 3. What could I plug into the second factor to make y 0? Positive 1. So these are my x-intercepts. So I'm going to take my graph and I'm going to put one at positive 3 and positive 1. Okay, everybody do that. And let's see if you have any questions up to this point. Does everybody understand how that happened? What can I plug in here for x that would make that 0? 3. What can I plug in here that would make this factor 0? 1. And that's how we get our x-intercept. Now, a few minutes ago I said that a parabola is always symmetric. So, the line of symmetry would have to be halfway in between those 2 points. What is the equation for this line of symmetry? It's x equals, and what is the x value for that line? 2. Because halfway between 1 and 3 is 2. All right. We also said that the vertex, that highest or lowest point of a quadratic, always falls on the axis of symmetry. So, if we know it's on here, if we know the x value is 2, could we plug that back in to figure out the y value? All right, so let's find the vertex now. To find the vertex, we're going to say y equals, let's plug in this 2, because we know the x value is 2. So what is 2 minus 3 times 2 minus 1?
-1.
What is 2 minus 3?
-1.
-1. What is 2 minus 1?
+1.
Yeah. And what is -1 times +1?
-1.
-1. So our vertex is at the point 2, -1. So what we can do is come down here to the point 2, -1, and plot our vertex. And then we can sketch our graph. It looks like this. All right. I'll give you a second to make sure you have everything from that first example written down. And then we're going to do some more together. gave the vertex, the axis of symmetry. Now let's think about the domain and the range. The domain, it keeps going left forever, it keeps going right forever. So the domain is from negative infinity to positive infinity. Now range is the set of all possible y values. And we always write it from least to greatest. So when we're looking at this graph, we go from the bottom to the top. What is the lowest y value here?
-1.
-1. So this goes from -1, I didn't write the negative in front, -1 to the top. Well, the top goes on forever, doesn't it? So how do we describe that? Infinity. And there's our range. Okay, on this one, we want our x-intercepts. So what would make this factor equal 0?
-2.
-2. What makes this factor equal 0?
+4.
Okay. So we have an x-intercept at -2. We have an x-intercept at +4. Can you tell by looking at it what's halfway in between? 1. If you can tell by looking at it, great. If you can't, you can always add these up and divide by 2. That always gives you halfway. Averaging, that makes sense, doesn't it? Gives you halfway. So, we know that that axis of symmetry is at +1. So we're going to draw in the axis of symmetry. Everybody got your axis of symmetry? All right, so we're going to say the axis, can I abbreviate axis of symmetry, AOS?
Yeah.
Okay, so our axis of symmetry is a line. Because it's a line, guys, we always have to say x equals 1. That describes this vertical line. Now we have to find the vertex. What do we know the x value is at the vertex?
1.
1. So we plug in 1, and to find the y value at the vertex, what is 1 plus 2 times 1 minus 4? Okay, so 1 plus 2 is 3. And 1 minus 4 is -3.
-9.
Good. So our vertex is the point 1, -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so we'll put it right here on the axis of symmetry, and then we create our parabola. Okay, what's our domain? Every time.
Negative infinity to positive infinity.
Negative infinity to positive infinity. And for this one, the range, from bottom to top, what's the lowest possible y value?
-9.
-9.
Excuse me.
Yes. And it goes up forever. How do we describe up forever? Infinity. Okay, number 3, I'm going to get you started on, and then I want you to try to finish it, okay? So the first thing we're going to do is figure out what x values make this equal 0. Well, this one would be what? -4. Now this one,
0.
very good. When it's all by itself, or even if there's 2 times x, if we plugged in 0, does it make that 0? Yes. So those are my x-intercepts, -4 and 0. Okay, now you start graphing. If you're not sure what to do, I want you to ask me. And if you'll notice, up at the top in the notes that I typed out for you are the steps. What do I need to do every time? Okay, so everybody's trying. You're in second period. Miss Goodrich is in there, and she can help you if you're not sure exactly what to do.
Right here, it's always on your axis. Everything's right. Hand down.
This is right.
Yeah.
Slide these.
Yeah, you gotta watch out. You gotta be careful out here, bro.
Let's go with the instructions.
All right.
So that when Andrew gets back, when Andrew gets back.
Yeah, she was.
That's like
From there, you gotta figure out your axis.
Okay. All right. So this is the first one we tried to do by ourselves, and it's got a couple steps. So probably going to need a little help to start with. But let's go in and go through these steps real slow again. First thing we're going to do is plot those x-intercepts at -4 and 0. The next thing you're going to do is try to figure out the axis of symmetry. Can you look at it and tell it's halfway in between? Or do you need to add these two up and divide by 2? Whichever method you need to do is the approach you should take. So if you can just look at it, go for it. But if you need to add up these two numbers and divide by 2 every time, do it that way. -4 plus 0 is -4. Divided by 2 is -2. So my axis of symmetry is x equals -2. So we're going to draw that in. Oops. Did it get crooked or straight? Crooked. Okay. Okay. So now what we have to do is find the vertex. Once we have the axis of symmetry, we know the vertex is on here. So when we find the vertex, we do that by taking this -2 and plugging it in. What is -2 times -2 plus 4? Well, that's -2 times +2, and -2 times +2 tells me my vertex is at -2, -4. This gives me -4. And you can plug that straight into your calculator if you like. So -2, -4. So I'm going to come down here on that axis of symmetry, down here to -4, and plot the vertex, and then make my curve. Okay? Now every time the domain is from -infinity to +infinity, and this time our range, all the y values from least to greatest. So -4 to infinity. Now today, in this class, we're only going to practice parabolas that open up. But these parabolas can open up or down. And what would make it open down would be if this was negative. So today we're practicing all quadratics that open up, but they can open down, and we'll practice those later. Okay, now look at number 4. It is not factored. How would number 4 factor? Good. X minus 2 times x plus 4. So it's very similar to number 2, isn't it? It's just our signs have changed. Very similar to number 2, but our signs have changed. So this time, our x-intercepts, what would make this first one, this first factor, equal to 0, +2, and -4. Okay? So we're going over to +2, and we're going back to -4. Okay? So when they're not factored, that's our first step. Factor them. Alright, where's the axis of symmetry?
-1.
Halfway in between. So the axis of symmetry is always a line. So we're always going to say x equals, and if you can tell it's at -1 without adding these up and dividing by 2, that's fine. Just say x equals -1. If you can't tell, we add these two numbers up and divide by 2. Now, our vertex is going to be the point -1, because the vertex is always on the axis of symmetry. And then we can plug in -1. I'm going to change to green here. If I plug in -1, this becomes -3, and this becomes +3, because -1 minus 2 is -3. -1 plus 4 is +3. What is -3 times +3? -9. So my vertex is the point -1, -9. And we can plot that on our graph. And then draw in our curve. And later on on this week, we're going to talk more specifically about what this curve does, what it really looks like in between here and here. All right, domain,
In negative infinity to positive.
negative infinity to positive infinity. Range, least to greatest y values. What's the least y value? Negative 9. What's the greatest y value? It goes on forever. We represent that with infinity. Good. Okay. What I'm going to do now is end the video because the rest of the problems work the same way. If you're in Miss Peavy House's class, I will post the solutions to Miss Willoughby's website. You can link to it from the Stars Mill website if you're interested in seeing. Those of you that are in Miss Willoughby's class, let's try it. Let's get to work.